Okay, so last time we talked about the colon operator and how we can make an array very quickly using the colon operator. Today I want to talk about the two functions, the Linspace function as well as the Logspace function. And essentially both of these functions do the same thing as the colon operator, except you'll have more control over the grid or the spacing you're trying to work with. So the Linspace operator is essentially what it does. It allows you to indicate an initial point. So let's go ahead and type some variable equals linspace, and we're going to put something in these parentheses here, and what we're going to define as our first value is 1. This is our initial value, and then our final value we're going to say 10 just for the sake of the example, and then we'll put a comma and we're going to say 3, and this is essentially saying that I want to have 3 points between the value 1 and 10, and what it's going to do is it's going to give me 3 evenly spaced values. So if I press enter, I get 1, 5.5, and 10. Now you can make the argument with the colon operator. Let's just say d1 equals 1 colon 5.5 colon 10 does the same thing, but you see here it does not, because what it does is it gives you a starting point of 1. It's going to increment by 5.5, which gives you 6.5, but it doesn't reach 10, because if you're going to add another 5.5 to 6.5, it'll be the value 13. So you said you want to stop at 10, so 13 would be above 10. Therefore, in this case, you think you're going to start at 1 and you're going to end at 10 using the colon operator, but in this case it doesn't. So this is why using a function like Linspace, you have a clear-cut beginning and end points, in this case 1 and 10, and you're going to distribute it using 3 points. Now of course I'm going to press the up arrow on my keyboard here. If I do 1, 10, and let's say typically you wouldn't just use 3 points, typically you would have a lot more number of points. Let's just say I want to do 10, so enter, and that gives me evenly spaced 1, 2, 3, 4 up to 10, and then I'm going to do it one more time so you can see if I change my spacing to 100. So now I'm going from 1 to 10 using 100 points evenly distributed, and it will divide it accordingly that way here, and then now I have 100 points. If I look at my value up here and my size of my D array, it's 1 by 100. If I double click on it, and I see it looks like this. Now we'll talk about this in a later video, but let me show you how to make this easier to see, and let me just put it here. There's something called the transpose operator. So now this is an array, horizontal array. I can simply put an apostrophe at the end here, and it makes it a column or vertical array, and then you see it looks so much nicer, or easier to see and cleaner. And now you can see that you're incrementing by a specific value here evenly each time to reach 10. Okay, so that's essentially what the Linspace operator is. So if I double click on it here again, now it becomes a column, and you can use this for a table later on. Okay, so let's go and close that. So this was essentially the Linspace operator. It allows you to take a beginning value, a final value, and then some increments in between, and it'll divide those number of points accordingly, and you'll have an array of that size. Okay, and note that it's called Linspace because it's linearly spaced. Okay, similarly we can define a log space, and log space, as the name shows, is a logarithmic scale. Okay, now we have to be careful with log space because let me go ahead and clear the screen so we can have it up here. Okay, so if I define log space as another variable, okay, here, the inputs to this are going to be a little bit different, okay? Because now we're no longer in linear spacing, we're in logarithmic scale. So the first value here is going to be the initial value expressed as a power of 10. So let's just say I'm going to say my initial value expressed as a power of 10, I'm going to say 1, and then I'm going to say 3, and this is going to be my final value expressed as a power of 10, and I'll explain what that means in a second. And then I'm going to say 3 again, which is 3 data points. Okay, so I'm going to press enter so you can see the output, and you get 10, 100, and 1000. And the reason why that's 10, 100, 1000 is because the initial value is 1, so that means I'm taking 10 to the power of 1, which is going to be 10. And then the final value is 3, so that's going to be 10 to the power of 3, which is going to be 1000. So that's the log scale. And then so I have 10 to the power 2 is another one, so that's going to give me 3 points. I'm going to have 10 to the power 1, 10 to the power 2, 10 to the power 3. The reason why I have 3 of those is because I say I want 3 evenly spaced values, or logarithmic spaced values, starting at 10 to the power 1, ending at 10 to the power 3. So that's the difference between log space and linspace. Okay, essentially those are the two functions I wanted to introduce to you here. So let's go ahead and just say, okay, I want to. This is a common mistake. People put 10 and 1000 here when they want to do 1 and 3, and if you do this, you're going to get infinity. So this is 1 times 10 to the 1, and then meaning 10 to the power 10. Then the other one's going to be essentially 10 to the power 1000. It's going to give you infinite. So that's not what you want to do with log space. You don't want to put the log scale here. You just want to say the power 1, 10 to the power 1, and then it's going to be 10 to the power 2, and then final value is going to be 10 to the power 3. So this is the correct way of doing it here, where you get the log space. And if you want to have more spacing here, or let's just say I'm going to say I want to have ending at 10 to the power 4, you see now I have this multiplication factor in the beginning. Actually, I don't want to do that. Let's just go back to here just for the sake of display, and let's just say I want to have more spacings. I'm going to say 5 spaces. Okay, and it's going to do the spacings for me. I'm going to have 5 points. If I look at my size array, it's 1 by 5. And if again I can use the transpose operator here, press enter, and it's going to do it in a vertical or fashion. Okay, so this is these are the two functions you can use to define your arrays very quickly in linear space or logarithmic space, and the linspace is an alternative to the colon operator if you want more control over your beginning, ending values, and the spacing in between.